Hello guys, it's Daniel, and today I'm going to teach you how to find factors and multiples of a number, and then find the common factors and common multiples. I will also teach you how to find the prime factorization of a number. Yay! A factor is a number that fits into another number. For example, 2 is a factor of 4, since 2 goes in the 4 2 times. Blank also goes in the 4 evenly, and so does 4. And 4 times what equals 4? Well, 1. How do we figure out these things called factors? There's one technique called the curtain technique. And this acts like a closing curtain. Every positive number has 1 as a factor, so we can put 1 down. Now we have to figure out 1 times what equals 20. Well, 1 times 20 equals 20, so therefore 20 is a factor of 20. So now the next number is 2. And 2 goes in the 20 how many times? It goes in the 20 10 times. So 2 and 10 are factors of 20. 3, however, does not go in the 20, so we have to skip that. Does 4 go in the 20? Well, yeah, it does. So we now put 4 down, and 4 times what equals 20? 5. And so we have just closed the curtain from 1 and 20, the 2 and 10, to 4 and 5. So this means that 1, 2, 4, 5, 10, and 20 are all factors of 20. Also, if a number is prime, then the only factors that it'll have is 1 and itself. For example, 17 only has factors 1 and 17. So the next thing that we're going to learn is a multiple. A multiple is a number that another number can go into evenly. For example, 8. Let's find the first 3 multiples of 8. So all we have to do is in order to find a multiple, we just do 8 times blank equals blank. So we can start out at 1, and 8 times 1 equals 8. 8 times 2 equals 16. And 8 times 3 equals 24. I know I'm amazing at math right now. And of course the drawing. I know the drawing is beautiful. So those are the first 3 factors of 8. And since there are infinite multiples, because we have an infinite number system, we can go 8 times 4, 8 times 5. We could go all the way up to the multiple being 1024. And so this number would have to be 128. And this means, and in this case, both 128 and 1024, they're both factors of 8, or multiples of 8. So what is a common factor? A common factor is a factor that is shared by 2 or more numbers, while a common multiple is a multiple shared by 2 or more numbers. So a common factor. In order to find common factors, we first have to find all the factors. So let's find all the factors of 8. Does 1 go into 8? Yes, it does. And 1 times what equals 8? Well, 8 does. Does 2 go into 8? Yes, it does. So 2 times what equals 8? 4. These are all the factors of 8. And somehow I knew that there would be 4 factors. Yeah, 3 lines. How did this happen? So for 4, we have 1 as a factor, and 4 as a factor. Then we go up one more number, and it's 2, and that must be it because there's only 3 lines. Once again, there are infinite multiples. No. So now, all we have to do is find all the factors that those two numbers have in common. So, as we see, 1, 2, and 4. So 1, 2, and 4 are the common factors. So now we have common multiples. Just like normal multiples, there are infinite common multiples. For now, we want to find the 4 least common multiples, which are the multiples with the smallest value. So let's find it for 8. So we have 8, 16, 24, and 32. Now let's find it for 4. We have 4, 8, 12, and 16. Once again, how do we get these numbers? Well, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, and 8 times 4 is 32. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and 4 times 4 is 16. So now all we have to do is find all the numbers in common, and those are the 4 least common multiples. So we have 8 and 16. However, since 4 goes into 8 evenly, any multiple of 8 is a multiple of 4. So before, we had the number 128. Well, we know that's a multiple of 8, so that must be a multiple of 4. And then we also had the number 1024. And since that's a multiple of 8, that must be a multiple of 4. Now, the prime factorization of a number is when you break down a number to its smallest factors and all the factors are prime. So let's take the number 16 for example. So 16. So what we're going to do is make a factor tree. And basically a factor tree is going to break down the number all the way to its smallest factors. So 16, what times what equals 16? Well, it could be 4 or 4 or 8 or 2 or other things if you went into decimals, but you're not supposed to do that. So let's start with 8 and 2. And this is why we did this, is because 8 times 2 is 16. So 8 and 2 equals 16. So now 2 is a prime number. So therefore, we don't make that break down any longer. That stays. So now we have 8. So now we need to break that down and do 4 and 2. Because 4 times 2 is 8. And now 2 is prime. So we don't break down that 2 anymore. We can still break down the 2. So, or the 4. So 2 times 2. So 2 and 2. And now both numbers are prime, so we can't break it down anymore. So now we know that the prime factorization of 16 is 2 times 2 times 2 times 2, or 2 to the 4th power, because the ending factors are 2, 2, 2, and 2. And if we were to do 2 times 2 times 2 times 2, 2 times 2 is 4, times 2 is 8, times 2 is 16. Now, why on earth is this important? Because, well, I mean, why did you learn all this? I bet you're asking that right now because, well, yeah. So look at this problem, 63 times 30. You could use paper, in which you would use 63 times 30, 0, you put the 0 down, so then you put another 0 down, 3 times 3 is 9, 3 times 6 is 18, add it up, it's 1890. So this strategy that I'm about to show you is probably better for bigger numbers, because you can just use paper in order to do this. So first, we want to break down the numbers to their prime factorization. So 63, by the way, I already did the math, 63 equals 3 times 3 times 7. 3 times 3 is 9, times 7 is 63. And 30 equals 5 times 2 times 3. 5 times 2 is 10, times 3 is 30. So now, instead of multiplying 63 times 30, is what you can do is you can multiply them any way you want. So 3 times 3 times 3, so we use that, and that. 3 times 3 times 3 is 27. Now we can multiply that by 2, which is a pretty easy set of multiplication. So 27 times 2 is 54. So we can now take off the 2. And 54 times 5 is 270. Now you may think, how did you figure out this so fast? Well, I already had it written down. And plus is all you need to do. 5 times 50 is 250, or 5 times 5 is 25, and then add a 0 to the end, so that's 250. 5 times 4 is 20. 250 plus 20 is 270. Woo! 270 times 7, that's all you have to do is break it down. 200 times 7, or 2 times 7, then put 2 zeros at the end. 1,400. 7 times 7. I didn't fix this from before, whoopsie. So 7 times 70 would be 490. Because 7 times 70, so that's 490. Of course, you can also do it 7 times 7 is 49, and add a 0. So now all you have to do is add it up, and then it'll end up equaling 1,890. You can also do it any other way you want, meaning is all you really have to do is you could do 3 times 2 times, you can do whatever you want, yay. And also, if you were to become an engineer, a scientist, or an architect, you may also have to use these skills. I hope you learned a lot about factors and multiples. And now, for a song.
There's a sad sort of clanging from the clock in the hall, and the bells in the steeple too. And up in the nursery, an absurd little bird is popping out to say cuckoo, cuckoo, cuckoo. Regretfully they tell us, but firmly they compel us to say goodbye to you. So long, farewell, I'll be the say goodnight. I hate to go and leave this pretty sight. So long, farewell, I'll be to say adieu. Adieu, adieu, to you and you and you. So long, farewell, au revoir, I'll be the same. I'd like to stay and taste my first champagne. So long, farewell, I'll be to say goodbye. I leave and heave a sigh and say goodbye, I'm glad to go. I cannot tell a lie. must I. So long, farewell. Auf Wiedersehen, goodbye.
So anyway, I guess we have to go. Okay, bye. Yeah, that's it. Bye.